Hello everybody, this is Todd Frazee and this is the tutorial for the 7312 slide stop cam assignment. So you should have already modeled this and we are going to now program this. Planning on this part, I see our first operation and it's going to probably cut everything we see in the front view, and we have a tight tolerance on our interior rectangle, so we're going to want to make sure we accommodate that for finish passes in case we need to cutter comp that. Then we'll flip it over and then we'll have this, yes, it's a 7-sided part completed with the tapped hole already on it. We'll stand it up on end to do the side view work, and then stand it up, tilt it. We should be able to put the part aligned with one of these chamfers to face the spindle normal to cut the final 1032 screw hole. So this looks like it's a 4 setup part, and we're going to look at our traveler before we start and look at what stock size is planned for this. So we have a 1 inch by 1/2 inch bar, and the pieces will be cut to 2 inch and 50 thousandths plus 100 minus 0. And so we want to clamp on the bar sides of it. And so in our drawing, we're actually going to need to rotate this so that the 1 inch 360 dimension is initially clamped in the vise. In a slightly different orientation than what we're seeing here. Okay, so let's get started. You're going to open up Fusion, and you're going to open up your data plane. Open up your data plane, you're going to open up your part. Okay, it should look something like that. And we're gonna plan on our stock first. So our first operation either needs to be like this or like this in the vise. So the semantics is, do we cut, which side do we cut first? I'd suggest we cut this side first. That way we can cut most of the features within itself, so they'll be accurate to each other. And then when we flip it over for the second side, we're really just decking material off and maybe doing deburring passes around the edges. Then our third op will be stood up like this against the vise stop. We're going to drill and ream this hole, which will hopefully the reamer will take off the burrs of our threaded feature. And then the last setup, we would put it up on end and have it facing like this, and it'll allow us to use this face here as a indication spot for the our origin. Okay, let's go to it. We're going to set up our stock, and then we're going to set up our vise assemblies. That way we can have the all the operations planned out, have the proper vise setups and stuff when we get into the machining. Okay, so first our stock. We're going to look at this in the plan view, so let's look at it in front with it horizontal, the rectangular corner, square corner, 90-degree corner on the left hand side, and we're going to go and we're going to create a sketch on that front plane. Oh, excellent. It rotated it for me. Alright, rotate that back. And we're just going to draw a box around this. And before I go any farther, I'm going to minimize my data plane there. Don't really need to see all that stuff. Okay, so if we go review to go back to our sheet, we have 1 inch by 1.5, so the thickness is going to be 1 inch. So 1.5 by 2 inches and 50 thousandths. So let's do the width first. So this is 2 inches and 50 thousandths. Okay, we're planning on that. And in the other direction it's 1.5. Okay, so that's our stock size. And we're going to center it again. So a bunch of ways to do this. As I usually do, I'm going to draw corner to corner on the box. I'm going to right click on that entity, turn it into a construction line, and then we need to find center of this shape. And we draw another line. Let's just draw a line horizontal. Okay, I'll right click on that, left click, and then right click on that. Great. Turn that into a construction line. Gonna pick on our endpoint and select midpoint of the beveled side. So that should be centered with our part. And then on this end, we can just bring it back, highlight it, highlight the edge, and make it coincident. So the width of this line is centered, and it's centered on this right hand side because this is all equal length. That should be center of the part itself. Now we're going to do a relationship or a constraint of center to center on our lines, and it should equally space our stock around our part. Okay, we're going to hit finish sketch. And as we've done before, we're going to do an extrusion. We're going to do it in two sides. The side I have highlighted with the blue arrow is going to be the majority of the material. So it's going to be, 1 inch minus whatever we're going to skim off the top of this. So on side 1, let's do 970 thousandths, and then in the opposite direction we'll go 30 thousandths. That should add up to an inch. And instead of a cut, we're going to do a new body, and that should be okay. And now we're going to expand our bodies here, and if we highlight the actual part, we want to change the name of that to the part number 7312, and the other one we're going to call it stock. Okay, we're going to right click on the stock, and we're going to go down to opacity control and set the opacity to 50% so we can see our part within the stock. Okay, so we have our stock volume. We're going to take 30 thousandths off the top as our first operation. So we probably should just orientate it like we see it in this screen. We could orientate it this way. That way all our dimensions more or less come out to define all these features in this face. They come from this corner over here, so we want to maintain that. All right, so let's bring in, we're going to open up our data plane. We're going to bring in an instance of our vise. So we got the Sierra College generic vise. Bring that sucker in, and we're going to use the 1 inch and 5/8 parallels. And we're going to orientate our vise. Like so. We need to right click on this and unground it from parent so that it can still move around. Okay, and then we're going to do a joint. There we go. Hit OK. So there's our part in its stock, and then we're going to modify this number so that this part of the stock sticks to the workpiece. Which is our stock size. So that should be 1.5 inches. Okay, that's our first operation. Second operation, we're going to be flipping this part. We'll want to set up a vise stop on the left side that touches perhaps center to the right of here. That way when we flip the part about the y-axis, it'll register on the machined edge of this edge I have highlighted over here against the parallel. So here we go. We're going to go, we're going to hide this instance of the vise. We're going to bring in another instance of the vise. We're going to use the same height parallels for this operation. Okay, we want to position the vise in orientation to the part. So if I have my part and I want to hold it like this, I would need to rotate the vise 90 degrees this way. And 90 degrees this way, and then 180 in the last direction. And we'll hit OK. Now for this alignment, we're not going to use the stock, we're going to reference the machined edges. So our joint on the first pick will be just like we did last time. Top edge of the corner of the parallel. But our second selection we're going to do through intersection of edges. So we'll pick the one edge, the other edge, and they should come together where that theoretical intersection would be. It really will have a stop contacting the left side of the part. Is that okay? Alright, so operation 2 is going to deck down the remaining hat on top. We'll probably do some chamfer cutting around the edges to remove burrs. Then our next operation, we need to close the vise up. So if I hide the stock, my finished part measures 1.38. I'm sorry, 1.36. So we're going to change this value to 1.36. And that closes up the vise. Okay, so next operation, we want to do this hole here. You don't really want to drill onto an angle like this, so we need to drill it from the side that's flat, where it's best too. So we hide this current vise setup. We want to drill and ream the part from the orientation I have shown here with this face normal to the spindle. So let's bring in another copy of the vise. On this, we're going to need different height parallels. We don't want to just grip onto the very bottom of this. That won't give us a very square resultant. We want to grab onto about half the part, perhaps, or more. This part itself is almost 2 inches high width. No, I'm sorry, it's 1.5 inches width. So let's go with some shorter parallels and see if we can use those for the last two operations. So let's go with the 5/8 parallels version. If we have to, we can change that. You do want to use parallels. You rarely want to use just the bottom of the vise. And the reason being is you won't know without tapping it and moving the parallels whether you truly have the part flat against the surface. So you do still want to use parallels, even though held in there pretty deep. Okay, so I might have chose parallels that are a little too short. We'll see. Okay, so we'll accept that location for now. We're going to do a joint, and we're going to pick this corner, but we want the disc parallel with the vice jaw. And that way, when we go to do the origin off this piece, and we pick intersection, it orientates it the same way. And let's hit OK to accept that. I think that'll work. The part sits just above the surface, which is fine. And we're going to drill through. We do want to make sure our parallels aren't underneath where we're drilling. Don't want to hit that. Okay, then we'll change this distance to 0.75, which I believe is the thickness of our part. And so that operation should be clamped, something like that. You are going to want to make sure this is all deburred pretty well here. And again, you don't have to, when you set it up in reality, you don't have to have this flush with the edge. What you do need is your stop touching that. That's where your origin is going to stay. If you set that up wisely, your X and Y location won't change. You'd be just changing your Z height shift to compensate for the different size parallels. Okay, we got one more operation to set up, and so we're going to hide this instance of the vise, and we're going to bring in our last operation. And we're going to use the same size parallels, so we're going to use the 5/8. I like using the 5/8 as opposed to the 1/2 inch, because it gives you enough room to get your calipers under there and measure the part while it's still in the machine. Okay, so our next operation, we actually are going to have our part in the vise like this. So, one, I need to flip the vise around 180 degrees. In that direction. Then we're going to rotate it 45. Because that's the angle of our chamfer. And then we should be able to move it around. Space. Get it somewhat close. Okay, so let's take a look at this. We're going to do a joint with the top of our parallel. We want the disc parallel to the vice jaw. And then on our part, we're going to do the intersection of two edges, which will be this edge, which is now vertical, and this edge, which is horizontal. Okay, we're going to rotate that to 135 degrees and hit OK. Alright, so we have our part aligned on the parallel in such a manner that our edge here is vertical. That's a 90 degree relationship, gives us this threaded hole normal to the spindle. And I'll change this to 75 3/4 inch width. Okay, so that's our last operation. Okay, so we got our operations in order, each setup with the vise in the proper orientation.